Another common type of problem that they deal with linear systems are problems dealing with coins. In this particular example, it says on the table there are 20 coins. They're made up of quarters and dimes. Their total value is $3.05. How many of each kind of coin are there? Now, just because I love to do this, because I am a gen ed instructor, I do want to point out one thing before we work on this problem. We have things in the English language called homonyms, words that sound the same but are spelled differently. And if they're spelled differently, they most likely have different definitions. Notice here that we're talking there, T-H-E-I-R. There is the possessive pronoun. Okay? It's talking about whose value? It's these guys, these quarters and dimes. It's theirs. They own it. It's their ownership. So that's why you use T-H-E-I-R. At the end, though, it says how many of each kind are there. There, in this case, is out there, that place. Okay? And then just so that we are well aware, there, which is our T-H-E-Y apostrophe R-E, is a contraction. It means two different words. They are. So it's they as in those two people over there, those two people over there, are something. Okay? So make sure, if you are not sure, replace your word with they are to see if it's supposed to be there with the apostrophe. Or if it's a place, it's T-H-E-R-E. If it's owning or a possession, that's when you have the T-H-E-I-R. I would be remiss if I ended up not taking advantage of teaching about there, and there. Okay, now let's go back to our problem. All right, first of all, we have coins. Once again, identify our variables. What are we trying to find? Each kind of coin. Well, what kind of coins do we have? Oh, we have quarters and dimes. So I would say let Q equal the number of dimes. No, of quarters. And let D equal the number of dimes. So that's talking about our coins. Now wait a second, it told us how many total coins we have. We have 20 coins. So our first equation will be, we'll take the number of quarters, which is Q, add that to the number of dimes, which is D, and that'll give us our total number of coins, which is 20. So now we look at the next problem. The next equation gives us a value of $3.05. Okay, well once again we need to assign the value to our quarters and dimes, like we did with the children and the adults in the play problem. What's the value if I have 3 quarters, if the number of quarters I have is 3, how do I find that value? Well, we take that times the 25 cents that it's worth. Okay, well, I don't really like dealing with decimals, so I'm going to say that the quarter is worth 25 cents. So 25 cents times Q would give me the number of cents that I earned from my quarters. If I do cents there, I have to do cents for my dimes. Dimes are 10 cents. So I take 10 times the number of dimes I have. That's going to give me the value of cents that I got for my dimes, and that's going to equal the total value. Okay, in this case, this gives me a value. Taking the 25 times Q gives me a number of cents, a value of those coins. Added to this is going to give me a value, but they gave us dollars. I just used everything in cents, so I have to convert the $3.05 into pennies, which just moves your decimal point over 2 spots to the right, so it's the same as 305 cents. And now I have my 2 equations. I always like to eliminate my smaller variable if I can, so that I don't have to deal with negatives. So I am going to get rid of my d's. I have 10d over here, so I need negative 10d to add to it. To make this negative 10, we're going to multiply this entire equation by negative 10. Once again, I'm just going to rewrite that underneath. That's going to give me negative 10q minus 10d is equal to negative 200. Okay. Add them together, 25Q and a negative 10Q. Same thing as 25 minus 10. Gives me 15Q. 10D minus 10D cancels out as it should. Equals, we drop that down. 305 minus 200 is 105. Then to get Q by itself, we of course divide. And we end up with Q equaling 7. So that means that we have 7 quarters. Once again, read the directions, the question. We want each kind. So if there are 7 quarters, we had 20 total coins. That means 20 minus 7, or the number of dimes, is 13. 13 dimes and 7 quarters. This is how you might set up a coins problem. Now, sometimes they're not always worded like that. Say they don't always give you the total number of coins. Maybe they compare the number of dimes to the number of quarters. But this gives you an idea of how to set up the values on it. Anything else, you may want to read some of your example problems in the textbook to get an idea of how to set it up if they don't tell you the number of total coins, and instead they compare the number of quarters to the number of dimes. That might be beneficial. Read the book.